Let's just dive right in. You know that feeling, right? Staring down a massive, incredibly intricate IBM application and feeling, well, a genuine chill run down your spine. You know exactly the environment I'm talking about. It's this towering legacy system, and the original developers, yeah, they retired like half a decade ago, taking basically all the institutional knowledge out the door with them. So every time you need to make even a tiny tweak, it feels like you're waking up this terrifying monster of hidden dependencies. Like, picture this. You just need to change a 10-character field to 12 in what looks like a totally harmless display file. You make the change, compile it, and think you're totally in the clear. And then, bam! It's 2 a.m. and you realize you just brought down the entire critical nightly batch process. Why? Because of some hidden dependency in a program that was compiled 10 years ago. It's just this dense, invisible web, where touching literally one element can break a dozen programs you didn't even know were there.
So welcome to this explainer. Today, we're going to unpack exactly how you can transform that terrifying monster into something, well, entirely manageable. Instead of completely drowning in a chaotic sea of legacy code dependencies, what if you could actually gracefully surf that massive wave without completely wiping out? Today, we're exploring a really fascinating automated dependency and build management system specifically for IBM I. It's a massive architectural breakthrough that's currently in its test phase and gearing up for release. And look, why is stabilizing this code so absolutely crucial right now? Because modernization is just moving faster than ever. If your underlying foundation is shaky, trying to slap new web interfaces or API layers on top is essentially like building a skyscraper on sand. So we're going to dig deep into how this system stabilizes your environment, fiercely protects your long-term investments, and, let's be honest, most importantly, makes the day-to-day life of a developer infinitely less stressful.
Real quick, here's our roadmap for today. We'll start with the IBM I complexity trap, then look at the automated site manager, dive into the intelligent build process, check out smart workflow and error handling, cover supported languages and objects, and finally, finish up with protecting your legacy investments. Let's get to it.
Section 1. The IBM I complexity trap. Okay, so the absolute core issue every veteran developer out there faces is what we call the ripple effect. Modern ILE applications on the IBM I, as you well know, are not just simple, isolated, monolithic programs anymore. They're sprawling, highly interconnected networks. You've got field reference dictionaries dictating database sizes, physical files storing the data, logical files providing your access paths, display files for the UI, plus a whole myriad of SQL views, modules, and service programs just binding the whole shebang together. So when you manually change a single base element, that change literally ripples violently outwards. Suddenly, you're forced to manually track down and recompile every single logical file, module, and program that relies on that specific buffer size. And if you miss even one compiled module during those manual updates, you probably won't even know until a user hits that specific routine in production, triggering a dreaded level check or even a catastrophic crash. The sheer number of developer hours lost to this manual tracing and testing is just staggering, and the risk of a runtime error slipping through, sky high.
Moving on to Section 2, the automated site manager.
Now, the contrast in methodologies here is where the paradigm truly shifts. I mean, the old way of managing these systems was fundamentally chaotic, right? It relied heavily on guesswork, manually parsing through cross-reference tools, and basically crossing your fingers during manual testing, hoping you didn't trigger some massive runtime error. But this new approach, it throws the guesswork out entirely. Enter our hero, the automated site manager. It utilizes native IBM I APIs to interrogate your system. And here's the absolutely crucial part. It extracts information directly from the compiled objects themselves, not the source code. Because let's face it, source code can be notoriously out of sync with what's actually running in production. By taking this strictly object-centric approach, the tool pulls the ultimate truth straight from the machine itself. It maps out all recognizable dependencies and automatically generates a really precise, heavily structured work plan for any necessary updates. It's giving you a perfectly predictable roadmap for compilation. No more guessing.
And the core benefits of this? They completely transform the daily development cycle. First off, you're looking at massive time savings by fully automating all those incredibly tedious, routine tasks of finding and compiling dependencies. Second, by automatically handling that complex, cascading ripple effect we just talked about, the system virtually eliminates runtime errors caused by missed object-level checks. It's a total game changer. And third, we definitely have to talk about this: investment protection. So many organizations have decades of tested, hardened, absolutely bulletproof business logic locked up in classic RPG and DDS. Throwing all that away just to rewrite from scratch? Financial nightmare. This tool is perfectly optimized for the maintenance and expansion of existing systems. It seamlessly marries that classic RPG infrastructure with modern SQL views. Honestly, it's kind of the holy grail for IBM I shops looking to modernize without destroying their foundation.
All right, Section 3, the intelligent build process.
Let's look under the hood. The true secret sauce here is bidirectional impact analysis. To understand why this is so powerful, let's just imagine a hypothetical top-level program that's checking warehouse inventory. In Step 1, the system looks at that inventory program and documents the specific modules it requires to function. Then, moving to Step 2, it drills down into those modules, scanning for the logical files, copybooks, and includes being used for the stock check. And finally, in Step 3, it traces those logical files all the way down to their massive foundational physical files and field references. Now, because it's bidirectional, the system intelligently reads these dependencies both upwards and downwards. So, say you alter the base physical file holding 10 years of inventory data, the system instantly calculates exactly which logicals, copybooks, modules, and top-level programs above it desperately need a rebuild. The source reference is embedded right there in the object, meaning absolutely nothing slips through the cracks.
If you've ever spent your Friday afternoon manually untangling a messy web of binder directories, just praying you link the right modules together before the weekend, well, this is where you can breathe a massive sigh of relief. Normally, executing a create program command, or CRT-PGM, requires you to explicitly specify every single module involved. It's an error-prone, frustrating process, and it so often results in duplicate symbols or unresolved references. But with this system's automated ILE optimization, those headaches completely vanish. Actually, let me rephrase. It's incredibly simple. You just provide the new program name and the program entry procedure, the PEP module. That's it. The tool takes over, automatically hunting down and pulling in the necessary modules to make the program function. It strips out redundant modules automatically, and because it extracts required modules straight from the program object, the dreaded task of manually maintaining binder directories literally becomes entirely obsolete.
Section 4. Smart Workflow and Error Handling.
So, when you initiate a change, the system algorithms calculate the absolutely optimized order of operations to rebuild your environment without conflicts, creating this brilliant central work plan. Now you can run this plan in a few ways. There's batch mode, where it quietly handles the heavy lifting in the background and just sends you a single status message when it's done, perfect for those massive unattended system updates. Or you can run it in interactive mode. This actively pauses to give you immediate error displays, letting you dive straight into spool files or your code editor to debug on the fly. But the real standout feature, the parameterless mode. Just imagine this. You kick off a massive cascading compilation at 4:55 p.m. and something deep in the stack throws an error. Normally, you're staying late to fix it and restart the entire chain. With this system, the failed object simply stays in the work plan. You can pack up, go home, come back the next morning, fix the underlying code, and just run the tool without any parameters. It remembers exactly where it stopped and seamlessly picks up the remaining workload. How cool is that?
Moving to Section 5. Supported languages and objects. You know, broad coverage is really the lifeblood of any automated build system. If a tool leaves blind spots, your entire modernization effort can just stall out entirely. Well, this automated site manager boasts incredibly robust support right out of the gate. For languages, it seamlessly navigates RPG, SQL-RPG, and CLE. For system object types, it effortlessly manages commands, programs, and modules. It deeply understands your core database and interface architecture, handling physical files, logical files, display files, and printer files. And crucially, it fully supports the modern database architecture of SQL views and index aliases. By covering everything from legacy RPG setups to the newest SQL methodologies, it ensures literally no critical object is left out of the impact analysis. Oh, and the capabilities are still expanding. COBOL support and native handling for service programs are currently in active development for the next major release phase.
And finally, Section 6, protecting your legacy investments.
Physical files are never deleted. Permissions, triggers, and constraints remain completely intact. I really want to emphasize that this isn't just a feature. It's a strict, unbreakable law within the architecture of this tool. When you're modernizing your infrastructure, preserving data integrity is absolutely paramount. Deleting a physical file during a rebuild? Highly dangerous. Doing so wipes out attached database triggers, tears down referential constraints, and resets those carefully crafted security permissions. Attempting to manually restore all those elements is a logistical nightmare that heavily risks your security compliance. But here, the system uses specific alteration commands to ensure that your underlying physical data structures are kept absolutely safe, retaining all their attributes. Even for dependent logical files, the automatic restoration of specific user permissions after a rebuild is currently being finalized. Your investment in your historical data remains securely locked down, no compromises. Which brings us to our final thought. We started our journey today by looking at that terrifying monster of legacy dependencies, the sheer risk of manual updates, and the overwhelming fear of breaking critical systems. But as we've seen, through API-driven system scanning, deep bidirectional impact analysis, and a highly intelligent, resilient work plan, you no longer have to fear that underlying complexity. You can actually leverage it. You can use it to build a faster, safer, and much more modern environment. So the question I want to leave you with today is this. Are you ready to finally stop fighting the complexity trap and start surfing the wave of automated modernization? Thank you so much for joining me for this explainer. I really hope it's provided a clear, empowering vision of exactly how you can permanently stabilize and confidently modernize your IBM legacy systems. See you next time.